In this video, we'll go over the different problem types that appear on your final exam review. So the first one we're going to take a look at here is problem G, one of several problems where we're asked to just do some simple computation. So I'm trying to add these two numbers together, but notice I have an absolute value here. And so absolute value, we kind of consider that the same as parentheses in the order of operations. So I want to evaluate, or I want to take the absolute value of negative 17 first. So I would say, okay, the absolute value of negative 17 is going to end up being positive 17. Then I'm going to add positive 17 to negative 14. Notice these parentheses here are not an absolute value. So that 14 is going to stay negative. Negative 14 plus positive 17 is going to give me a positive 3. H, we're adding mixed numbers. And in order to add any sort of fraction, we're going to have a common denominator. Notice we don't have that there. We have denominators of 2 and 5. So the first thing we're going to have to do is build these into like fractions. So our common denominator with 2 and 5 is going to be 10. The missing multiplier in the first fraction is 2. So times 2 times 2, which gives us a denominator of 4. Second fraction, our missing multiplier is 5. So times 5 times 5. Now that I have a common denominator, I can add these together. Let's add the whole numbers. 7 plus 3 would give me 10. And then 4 tenths plus 5 tenths would give me 9 tenths. We check to see if we could simplify 9 tenths, which we can't. So that's our final simplified answer. Next problem we'll take a look at is question 11. And in question 11, we're asked to evaluate, which means when we get done with this expression here, we have it down to a single answer, or a single number answer. So let's take a look. It's order of operations, and we have braces, brackets, and parentheses. All of these things kind of need to be done first, but we kind of work our way inside. So first we say, okay, we have braces here. We got to work inside of that, but inside the braces we have brackets. And so we're going to try to start inside the brackets, and then finally inside the brackets we have parentheses. So that parentheses is where we're going to start. We're going to start by adding that 3 and 4 together. So I'm just going to copy the rest of this down. The answer to inside the parentheses there is 7. Then I would have bracket, brace, minus 1. All right. Still working inside the brackets now. The next thing we're going to do is the multiplication here. Negative 2 times positive 7 will give us negative 14. And I'll copy everything else down now. Okay. Now we're working inside the brackets there. 6 minus 14, well, that's certainly going to end up with a negative answer there. So let's see, 6 minus 14, that'll give us negative 8. Copy everything else down. It's real important that we copy everything as we go. You know, half the battle here is just keeping this stuff organized. So now we've got our bracket down to a final simplified answer. So now we're going to look to see if we could do something inside the braces, and we can. We have this subtraction to deal with here. We're going to do that next, but notice we have a double negative, minus a negative 8. So that's actually going to turn into plus a positive 8. So I really have in there negative 12 plus 8, which would give me negative 4 inside the braces, and then minus 1. So last step is negative 4 minus 1, which will give me a final answer of negative 5. Next problem, problem 12. Here we're asked to simplify. We're not going to get this down to a final, a single number answer here. We're just going to have a simplified answer. Again, this is very similar to order of operations. We would start by looking inside of these inner parentheses to see if we could add these together, but we can't. I have a 2z and a 4x. Those are unlike terms. So the next thing I would do is look outside of the parentheses, see if there's anything I need to distribute, and there is. I need to distribute this negative now to both of those terms. So I'll just copy everything else down. When I distribute a negative to that positive 2z, it'll become negative 2z. Positive to negative, negative to that positive 4x will become negative 4x. All right, let's see now if I can simplify inside the brackets. I can. I have like terms here, 6x and negative 4x to combine. So when I combine those together, that will give me 2x minus 2z. Now, nothing inside the brackets that I can combine together, so I would look outside the brackets and see if there's anything to distribute. There isn't. This is just an addition sign out here. So now I'm just going to see if I can combine my like terms. This was a z here. So I do have some like terms there. I have a positive 12z and a negative 2z to combine. So that would give me a 10z plus 2x for my final simplified answer. Okay, question 15. I'm asked to solve this equation. So the first thing I always do when I'm solving an equation is see if I can simplify either of the sides. I'm thinking both sides here can be simplified. On the left side, we would distribute this negative. The first step. On the right side, we have a negative 4 that can be distributed there. So let's see, minus 12 minus 8y. Now I'm going to see if I got any like terms to combine. On the left side I do. I have 3 minus 3, so 3 minus 3, that's going to go away. So all I'm left with on the left side then is negative 5y. On the right side I have some y terms to combine here. 3y and negative 8y. That's going to give me negative 5y minus 12. Alright, I'm done simplifying now. Next thing I check is to see if I have variable terms on both sides, which I do. So now I would try to get rid of the smaller one. Well, they're both the same, so it doesn't really matter. I'll just say, okay, add 5y here and add 5y here. But notice what's going to happen now is our variable terms are going to drop out. So on the left side, I'm left with 0. On the right side, my variable terms drop out again, and I'm left with negative 12. So we just need to recognize what this is. When the variable terms drop out, I either have infinite solutions or no solutions. If it's a true statement, I have infinite solutions. If I have a false statement, then it's no solutions. And notice here I have a false statement. 0 equals negative 12. It's not a true statement. So this is a case where we have no solution. Question 18. We're asked to solve this inequality and then graph the solution in interval notation. Okay, so we're going to solve it pretty much the same way we would as if we had an equation here. I'll start by distributing this negative 2 to simplify this left side. So let's see, 7x minus 10 minus 8x less than or equal to 8. Combining my like terms here, 7x and negative 8x, that's going to give me a negative 1x basically, or negative x, either way, minus 10 less than or equal to 8. Okay, trying to get x all by itself, so I would add 10 to both sides now. That's going to give me 18. Now to get x all by itself, I'm going to have to divide both sides by negative 1. But remember, in an inequality, if I multiply or divide both sides by a negative number, I need to flip the sign. So before I come down here and start writing anything else, I'm going to flip my inequality sign so that I don't forget to do that. And let's see, on the left side I'll have just x. On the right side I'll have a negative 18. So it looks like x needs to be greater than negative 18. So if I looked at this on the number line, which you didn't have to do, but it really helps to visualize here, x has to be greater than or equal to negative 18. So let's say here's negative 18. X has to be greater than or equal to, which means I need to include negative 18 in as part of my solution set. So I'd use a bracket to indicate that. And then anything larger than that, so anything going off here to the right, is going to be part of this solution set. This number line just helps me visualize now what's going to happen in the interval notation. On the left end, or the smaller end of things, the smallest value that's going to work in this inequality is negative 18. I want to include it, so I use a bracket. Had I not wanted to include it, had this been a strictly greater than, I would have used a parentheses there. So the smallest it could be is negative 18. The largest it can be, well, it can go on forever off to the right, so we're going to end up at positive infinity. Now, since positive infinity is not an actual identifiable number, we never try to include that, so we're just going to use a parentheses around that positive infinity. All right, question 19. I'm asked to solve this equation, but notice this isn't our typical equation here. Notice we have an a squared there. So that makes this a quadratic equation. And the way that we solve quadratic equations at beginning algebra is we try to get everything on one side of the equal sign and 0 on the other. So I could either move the 7a and the 6a over to the left. That'd be a fine way to do this. Or I could simply move the 5a squared over to the right. However, if I move that 5a squared over to the right, it's going to make it a negative, and we're really not used to factoring that. So I'm going to move the 7a and the 6 over to the left. So I would subtract 7a and then subtract 6 from both sides. Subtract it from the left side and then subtract it from the right side. So that would leave me with 5a squared minus 7a minus 6 equals 0. All right, once we get here, we're going to try to factor, but it's really important that we have a 0 over here, because 0 is the only number that this process or this solution technique will work for. So once I get a 0 over there, now I'm ready to take a look and factor this thing. So I say, okay, two binomials. Last term is negative, so I know my signs have to be one positive, one negative. Let's start with this 5, because that's a really easy one to factor. There's only one way to come up with 5. That's really 5 and 1. So really what I'm going to have here is I'm going to have 5a times a. Now 6, we got a couple different choices there. We could either choose 6 and 1 or 2 and 3. And since we have different factors in these spots, in these first spots, we're going to have to switch these factors down here around a couple times till we get the right combination. So we're looking for a negative 7 as my middle term. So I'm just going to kind of mess around here. Let's see, 10 minus 3, that would do it. So I just kind of looked at this and I said, well, I put the 3 up here and where it stands. I put the 3 up here where it stood, and then I'm already going all the way to negative 15. That's too high. Then I tried the 2 over here. That gave me a negative 10 when I multiplied the outsides. That'll give me negative 10. That's close to negative 7. And then I said, oh, what if I put the 3 over here? Sure enough, the insides then are going to be a 3a. So outsides are negative 10a, insides are 3a. That gives me the negative 7a that I needed there. So that's the factoring. I'll erase this kind of scratch work here. I was thinking about the factoring. All right, now that I have it factored, I want to figure out how to make each of these factors equal to 0. Let's start with this easy one over here, a minus 2. Well, that's going to be easy. If we choose a value of a equal to 2, that would make that factor 0. So there's one of my solutions. This one over here is a little bit harder to see. What we really want to have happen here is 5a plus 3. We want that factor to be 0. You may be able to look at that and say, yeah, it's negative 3/5. If you're not able to do that, let's go ahead and we'll write a little equation here and we'll just solve it. What we want is 5a plus 3. We want that to be equal to 0. So if I write that in a little equation, I can simply just solve it. So I'd subtract 3, and then I'd have 5a equals negative 3, divide by 5. And we get for our other solution then a equals negative 3/5. Now we'll take a look at question 22. Two of the longest running TV series are Gunsmoke and The Simpsons. Gunsmoke ran 97 fewer episodes than twice the number of The Simpsons. That's twice the number of episodes of The Simpsons. If the total number of episodes for both shows is 998, how many of each show was produced? So what we have here is we have two unknowns. We want to know how many episodes of Simpsons and then how many episodes of Gunsmoke. It's important that we write these down in words as well. It's really going to help us frame this or understand what these variables are meaning. And what I'm always going to coach you to do, let's say, okay, so this is X here, and this one is Y there. Let's say the episodes of Simpsons. We know we have two unknowns here, so we're going to have to write two equations to solve this. So we're going to have a system of equations to solve this thing. So we're going to need two equations here. Let's go back and figure out if we can figure out how to write these equations. I think the easiest one to write here is the total. If the total number of episodes for both shows is 998. Well, if I add the episodes of Gunsmoke plus the episodes of The Simpsons, that has to total 998. That was the easier one to see. The next one here is this relationship. This next sentence here gives us the relationship between Gunsmoke and The Simpsons. That's going to be our next equation. It says Gunsmoke ran 97 fewer episodes than twice the number of the Simpsons episodes. So if I say, okay, this is Gunsmoke, X is Gunsmoke now, that ran 97 fewer. So 97 fewer means I'm going to be subtracting 97 from something. 97 fewer than twice the number of episodes as The Simpsons. And so Y is the number of Simpsons episodes, so that would be twice that would be 2Y. So there is my second equation. Now that I have a system of equations, I'm going to go ahead and solve. And notice this is set up great for substitution. Notice X is already isolated here. It's 2Y minus 97. So all I'm going to do now is plug that 2Y minus 97 back up into that first equation for X. So let's see what that would look like. It would say 2Y So here's what that would look like then. We would say 2Y minus 97. That's what I've kind of substituted in there for X. Plus Y is equal to 998. Okay, now I'm just going to simplify the left side. Notice I can combine like terms here. 2Y, positive Y there, so that would be 3Y minus 97 equals 998. Okay, and then I'm going to add 97 to both sides. Let's come up here to continue. All right, so on the left side now I'd have just 3Y. And if I add 998 and 97 together, it's going to give me 1095. Divide by 3. I get 365. So it looks like I've just found the number of episodes for The Simpsons. So this is a little old. This problem is a little bit old, seeing as there's only 365 episodes of The Simpsons. Gone way past that now. Okay, but anyways, back to the problem. Now we got to figure out how many episodes of Gunsmoke there are. And so all we're going to do is take this Y and substitute it right back in for here, and then we'll figure out what X is. So here's what that would look like. X then equals 2 times 365 minus 97. So let's see. 2 times 365 gives us 730. And then 730 minus 97 gives us 633 episodes. Now I'm running out of room here, but we would want to make a statement here. At least this, 365 episodes. You might want to write a full sentence here, but I'm running out of room on my screen for my answers. So we want to write 365 episodes of The Simpsons, and then 633 episodes of Gunsmoke. All right, take a look now at question 24. The Forest Service must determine how many acres will be needed to make an additional 22 campsites. If the existing 24-acre campground accommodates 55 campsites, how many additional acres will be needed and to accommodate this 22 more campsites? So this is a proportion problem, and our given ratio or rate here is this. In this case, it's a rate. It takes 24 acres to accommodate 55 campsites. So there is our given rate there. So let's see, 24 acres to accommodate 55 sites. Now, over here, we want to make sure we are consistent and say acres and sites. So let's see. Let's go back to the problem. So they want to make now 22 more campsites. So it looks like 22 more campsites. And the question then is, how many acres, that's going to be our unknown, will this take? Once we get our proportion set up here, all we need to do is take the cross products. So 24 times 22 has to be equal to this other diagonal, or cross product, which is 55x. So let's see, we'll take 24 times 22. (24 times 22 gives us 528. And then we divide by 55. (9.6). So now we want to answer the question. So we'd say 9.6 acres are needed for the addition of 22 campsites. Now we'll take a look at 26a. Here we're just going to try to remember our exponent rules to solve this. And so here if I'm multiplying, notice I have 5 factors of x there. If I multiply by one more factor of x, that would give me 6 factors of x there multiplied. So this gives me x to the 6th power. Now remember, if I take, a base times itself again, all we need to do is add the exponents there. That's kind of the shortcut. And it's understood that that's a 1 x to the 1st power there. So we'd say x to the 5th, and then x to the 1st, adding those together would give us x to the 6th. Same thing here. Y, I have 2 factors of y here and 10. So altogether, I have 12 factors of y being multiplied there. So that's A. B, power to a power. Basically what I have to do now with this third power is I have to take every single one of these factors in here to the third power. So if I take 2 to the third power, that's going to give me 8. X to the negative 5th, then raised to the third power. This is power to a power. I actually multiply these powers together. So that's going to be x to the negative 15th power there. Next one, y to the 4th, raised to the 3rd. Again, that's power to a power, so we would multiply. Y to the 12th. One last thing now is I need to get rid of this negative exponent. So notice just x is to the negative 15th power here. So I need to take the reciprocal of that, which means I need to move that factor of x down to the denominator. Since there isn't a denominator here, I'm going to go ahead and write one. So I'm going to have to write a fraction here, and now that x to the negative 15th started in the numerator. Now I'm going to move it down to the denominator. When I move it, it will make it a positive 15. Notice the 8 and the y squared, y to the 12th are good. They're positive exponents, so they're going to stay exactly where they are, which is up in that numerator. All right, now taking a look at C. Got this negative 5th power on the outside. Let's check the inside first to see if we can simplify anything on the inside. We really can't simplify anything on the inside. Let's deal with the negative part of this exponent first. The negative part of this exponent means we just need to take the reciprocal. So to write this as a positive exponent, I would just flip the inside here. So I'd have 2y to the 3rd over x to the 4th. Since now I flipped it, now that exponent now is going to be positive. Once I get here now, I'm going to go ahead and take every single factor to the 5th power. So let's see if I take 2 to the 5th power. Ooh, that's a lot there. Let's see, 2 to the 5th power. 2 to the 3rd power is 8, times 2 again is 16, times 2 one more time is 32. Y to the 3rd, that's power to a power. So that's going to become y to the 15th. Now down in the denominator, x to the 4th raised to the power of 5. Again, that's power to a power, so that's going to be x to the 20th. Next question we'll take a look at is question 32. So we're looking here at question 32, and we're asked to factor this expression completely. So anytime we're asked to factor, the very first thing we want to check to see is if there's a common factor in all of these terms. 6, 21, and 12, yeah, there is a common factor there. 3 is a factor of all 3 of those numbers. And if we look now at the variables a cubed, a squared, and a is a factor of all 3 of those as well. So what we want to factor out front here first is 3a. So let's see, I factor a 3a out of that first term, I would have 2a squared left. 3 out of the second term, I'd have negative 7a. And then finally 3a out of the last term would leave me with minus 4. Now notice inside the parentheses I have my traditional trinomial, something squared, a to the first power and then no number. So I'm going to try to factor this into two binomials. But I want to make sure before I think about factoring that I write this 3a down there first, because it's so easy to forget to bring that down once you get involved in the factoring. Now that I've brought it down, let's take a look. So we got to get 2a squared. There's really only one way to come up with that, 2a and a. And then we're supposed to get 4 on the end, and it's a negative 4. So notice one has to be positive, one has to be negative. I'm going to put the negative over here because notice outsides 2 is going to get multiplied by the negative there, and notice we're going to end up with negative 7 in the middle. So I'm thinking probably most likely we're going to need that negative over there to get multiplied by the 2. So let's see, options for 4 are 2 and 2, 4 and 1, and it really helps to write this down. So let's see, 2 and 2, if I put those in there, then outsides would be 2a, insides would be 2a, there'd be nothing in the middle. That's not going to work. 4 and 1 as they stand wouldn't work. That'd be 2a, negative 2a on the outsides, plus 4a on the insides. That's still not going to work. But notice if I switch these and put the 4 here and the 1 there, that's going to give me negative 7, because now outsides negative 8a, insides positive a to give me a negative 7a for the middle. So here is my final factored form of that trinomial. Taking a look at question 35. We're asked to subtract. We have some fractions here. Well, in order to add or subtract, we're going to need a common denominator. So we need a common denominator here, but in order to find that, the first thing I want to do is I want to factor this trinomial to see exactly what kind of factors I have going on in this denominator. So I'd say, okay, x and x. Everything's positive, so my signs have to be plus plus. Multiply to give me 21, add to give me 10. Well, that's 7 and 3. X plus 7, x plus 3. So now let's take a look at the factors I have in the denominator. I have a factor of x plus 7 and x plus 3 in the left, and a factor of x plus 7 in the right. To make these a common denominator, all I really need to do is multiply this right side by x plus 3. And then they would have the same denominator in the bottom. So now if I multiply the bottom by x plus 3, I will multiply the top by x plus 3. Alright, let's take a look at what we have now when we get done doing that. This fraction on the left really doesn't need to change at all. It already had the correct denominator. So I'm going to leave that numerator the same. X squared minus 5. Okay, right side, the denominator is going to match x plus 7, x plus 3. And notice we really never multiply these denominators, because later when we go to simplify, it's going to be nice to have them all factored out like this. But the numerators we do want to multiply so we can combine them together. So notice up here in this numerator, I really have an x minus 4 times an x plus 3. So when I go through and multiply those, I would get x squared minus x for my middle term, and then negative 12 for the end. If you didn't see how I do that, you can go ahead and just go off and multiply that through, and this is the answer you'd come up with. Okay, now that I have a common denominator, I'm ready to subtract. But notice I have to subtract every single one of these terms up here. I got to subtract the first, second, and the third. So let's see. Before we do that, though, let's write the denominator, and then we'll focus on the numerator. So let's see, x plus 7 times x plus 3. That's what we're going to get for our final denominator, because it's not going to change. Now let's look at the tops here. Start with my highest powered, which is my x squared. And notice I have x squared minus x squared there. So x squared minus x squared is going to give me 0. Let's go to the next power of x, which is just x itself. But notice I am subtracting this negative x. So that's going to end up being a positive x. Now our numbers up there, or our constant terms up there, negative 5 minus negative 12. And again, I'm minusing that negative 12, so I'm actually going to add that 12. So I have negative 5 plus 12, which is going to give me a positive 7. Notice now, this x plus 7, I want to think of that as one factor, and notice that matches one of my factors in my denominator. That's why one of the reasons why we leave this factored is so we can see that. We could simplify this out, divide out that common factor of x plus 7 to give us a final simplified answer of 1 over x plus 3. Okay, problem 38, we're asked to solve this equation. Notice it's got some ugly fractions in here, but it's nice that it's an equation. We can clear all the fractions out. All we really have to do is multiply by the LCD. So let's see, I'm going to take this whole equation, every single term in this equation, and I'm going to multiply it by the lowest common denominator here. Let's see, x, if I look at my x variables, for x and x squared, I would definitely want to multiply by x squared. That's going to be the LCD part for the variables. Numbers wise, I only have just this 3. So really what I want to do is I want to go through and multiply each of these terms by 3x squared. So let's see, I'm going to go and multiply it by the first one. Now before I multiply it, let's see the x's are going to divide out. One of these x's will divide out, so that would leave me with just 9x in the numerator, because one of those x's will divide out. Next problem, when I go to multiply here, notice the 3 is going to divide out before I multiply, so I would be left with just x squared. Finally, when we multiply by this term, the 12 over x squared, notice the x squared is going to divide out, so all I'll have left is 3 times 12, which will give me 36. As you can see, multiplying by the lowest common denominator has cleared all the fractions out of the problem. Now I just need to solve this equation, and it has an x squared in it, so that tells me this is a quadratic equation, so I want to use that strategy to solve it. So I'm going to get everything to one side, 0 on the other, which means I'm subtracting 36 from both sides. While I'm rewriting this, 0 on the right, this left side I'm going to organize in our traditional descending order here, so I'd have x squared plus 9x minus 36. Now what I'm going to try to do is factor this trinomial out, so I'd say, okay, x and x. Last term is negative, so my signs need to be plus minus. Factors of 36 that are 9 apart, because one's going to be positive, one's going to be negative. Well, that's 12 and 3. And I would want to make the 12 negative and the 3 positive. So 3 times negative 12 definitely gives me the negative 36. Notice here, outsides, negative 12x, insides, positive 3x. Oh, gives me a negative 9x. So I actually want to switch this. Good thing I checked that. I want to switch this here. Let's factor that again. So x and x, plus and minus, but we need the 12 to be positive and the 3 to be negative. Now that will give me a positive 9x for the middle term. So now that I have it correctly factored, I can go ahead and figure out what values I need to make each of these factors 0. So x plus 12, well, that's pretty easy. If I put a negative 12 in there for x, that would make that factor 0. And x minus 3, again, pretty easy. That would give me a value of 3. Positive 3 would give me 0 for that factor. One last thing to check here, though, is to see if maybe one of these solutions, if these solutions are valid. So I want to check to see if I plug these solutions back into my original equation, I don't get a denominator of 0 and make this expression blow up here. Let's see, if I put a negative 12, it's not going to make that 0 here or here. No problems at all. 3, nope, 3 is not going to do anything anywhere either, so both of these solutions are good. Had one of these things not checked out, we would have to remove it from our solution set. But in this case, they both checked out, so I would have 2 solutions to this equation. All right, next we'll take a look at problem 40. And in 40, we're asked to graph this inequality. Well, we first start with graphing this as if it was a line. So I'm really going to just think of it this way. Y equals negative 3 halves x minus 3. Notice this is in slope-intercept form, where the value in front of x is my slope, m, and this value at the end is my y-intercept, and we call that b. So to graph this, I'm going to start with my y-intercept, which is negative 3. That tells me this graph is crossing the y-axis, and remember again, this is my y-axis, that's my x-axis. This graph is crossing the y-axis at negative 3. So let's see, 1, 2, 3. There's one of the points on my graph. Now the slope can give me another point on my graph. And so the slope here is negative 3 halves, and notice the negative was written out front here. We can move that either to the numerator or denominator. It looks like I've already kind of started moving it towards the numerator, so I'll just go ahead and do that. Negative 3 over 2. And remember, slope is change in y over change in x. So if I start at my original y-intercept here and I have a change of y of negative 3, that means I'm going to move down 3. 1, 2, 3, and then change in x is positive 2, which means I'm moving to the right 2. 1, 2. Here's the next point on my graph. If I needed to get a third point on my graph, I could simply reverse that negative sign and do this. 3 over negative 2. It's still the same slope. Now notice if I had started my y-intercept here and I go positive 3, or change in y of positive 3, that would be up 3. 1, 2, 3. And then in the change of x, negative 2, that would be left 2. There's a third point on my graph. So now I'm ready to graph this line, but now I need to decide if this line is going to be a solid line or a dashed line. Let's go back and look. It was greater than or equal to, meaning this line needs to be part of the solution set. And the way that I communicate that then is with a solid line. All right. Now, I either need to shade one of these two sides. So I'm going to have a test point here. Check one of these points on either side of this line and see if it works. Well, this is a pretty easy point to test, this 0, 0. So I'm going to put 0, 0 back up into my original inequality and see what I get. I'd have this then. 0 is less than or equal to negative 3 halves times 0 minus 3. Well, lots of stuff is dropping out here, but I basically end up with this statement. 0 is less than or equal to negative 3. Well, that's not a true statement. 0 is bigger than negative 3. So since this point up here was not part of the solution set, that means all the solution points must be on the other side of the line. So I'm going to shade this side of the line then. All right, question 42. I'm asked to solve this equation by the substitution method. So what I'm trying to do first is isolate one of these variables. And notice x is already almost isolated for me. So I'm going to add 5y to both sides here. And let's see, then I'll have x equals 5y minus 9. Now I'm going to take that 5y minus 9 and substitute it into the other equation for x. So that is going to go right up here for this x in the other equation. So here's what that'll look like. Negative 2. Now instead of x, I'm replacing it with this 5y minus 9 plus 10y equals 18. All right, now I'm just going to solve this equation, so I would distribute the negative 2. So negative 10y plus 18 plus 10y equals 18. All right, so negative 10y, positive 10y, that's going to give me 0. So I'm left with this statement, 18 equals 18. So this is the same situation we ran into earlier, very similar to the situation we ran into earlier when we were just solving an equation with one unknown in a single equation. But it's the same thing here. Variables have dropped out. This indicates to me I either have infinite solution or no solution. Here I have a true statement. Well, a true statement tells me that here I'm going to have infinite solutions then. Had this been a false statement, it would be no solutions. But a true statement tells us we have infinite solutions to this problem. All right, taking a look at our last and final problem, which is 45. So it's a 20-pound mixture of almonds and hazelnuts is to be worth $2.65 per pound. If almonds cost $2.50 and hazelnuts cost $3 per pound, how many pounds of each should be used? So here, how many pounds of each should be used means we're looking for two things here. So we're looking for, let's let x equal the pounds of, let's see which one was listed first, almonds. And then y will be the pounds of hazelnuts. Okay, we're going to try now to write two equations. And I've always kind of coached you guys, we're over here in our equals part, we're always looking for the totals. Let's start with the easiest total, which is there's supposed to be a 20-pound mixture in the end. So that's one of my totals. To come up with that total, all I have to do is add the pounds of almonds, which was x, plus the pounds of hazelnuts, which was y, to give me a total of 20 pounds. The next total that I need down here is kind of a total price, or total cost. That's what needs to go here. So to come up with that total cost, it's not given in the problem. They don't say all in all here, this mixture costs so much. But they do tell us this, that they want this final mixture to be worth $2.65 per pound. So to come up with a total cost here, all I have to do is take that price, $2.65, times the number of pounds, which is 20 pounds, and that will give me a total price or a total cost. Now, how am I going to come up with that total? Well, I'm going to add the pounds of almonds at 250, so 2.5x. That tells me how much it's going to cost for the almonds, plus now how much it costs for the hazelnuts, which is $3 per pound, so that would be 3 times y. That would give me a cost of the hazelnuts, and altogether it's supposed to come up with 265 times 20. All right, let's do some multiplying down there in the bottom and simplify that out. So 2.65 times 20 gives us 53. So this equation here really is this, 2.5x plus 3y equals 53. That's the total cost that it's going to make. Now that I have my two equations written and kind of simplified, I'm ready to substitute and solve this. So I'm probably going to isolate one of these x's or y's up here in the top equation. Let's isolate x. I subtract y from each side. And so that equation would look like this. X equals 20 minus y. And now I'm going to substitute that 20 minus y right down here in this equation for x. So I'd have 2.5 times 20 minus y. 3y equals 53. All right, distribute my 2.5. .5 times 20 will give me 50 minus y, minus 2.5y minus 2.5y. Okay, I'm going to combine my negative 2.5 and my 3 there. Let's come up over here to finish this. So I'd have 50 plus 0.5y. Sorry, that was 50 plus 0.5y equals 53. Subtract 50 from each side. 0.5y, and then it's going to equal 3. Divide both sides by 0.5. Y then is going to equal 6. So now I'm going to take this, which is one of my answers, come right back up here and plug it in for y so I can find out what x is. So then x is 20 minus 6, or 14. All right, now I want to answer the question. They didn't want me to find x and y. I want to say then x, which was my pounds of almonds. So we have 14 pounds of almonds. And then 6 pounds of hazelnuts.